Hello everyone! Today, we're going to conduct an exciting experiment to explore how temperature, particle size, and mixing affects the solubility of sugar on water. Yes, you hear that right. Solubility is how well a substance like sugar can dissolve in a particular solvent, which is water in our case. Let's start with knowing the solubility of substances in different temperatures of water. But first, Charles is here to prepare our materials.
Alright, we're going to use sugar and rock salt as our substances and test them in normal water, hot water, and cold water to see what happens. We will also use equal amounts of sugar and rock salt when doing the experiment, and 3 spoons as our scaling rods. Now, let's label our glasses so we don't get them mixed up.
Thank you, Charles. Let us now proceed to our experiment starting with cold water.
Sugar dissolves more slowly in cold water because the lower temperature reduces the kinetic energy of water molecules, making them less effective at breaking apart and surrounding sugar molecules.
After a few minutes of stirring, we can see that the sugar has dissolved in the cold water.
Next, we'll use the same amount of sugar and repeat the process, but this time with hot water.
We can see that the sugar dissolves faster in hot water because the increased temperature causes the water molecules to move more rapidly, facilitating the breakdown of sugar crystal and their integration into the water.
Now, we have a room temperature water here with Chloe.
Sugar dissolves in room temperature water because the water molecules surround and separate the sugar molecules, breaking their bonds and allowing them to disperse evenly throughout the water. As we can see, the sugar also dissolves in the normal temperature water, but not as quickly as in the hot water. So, there you have it. In our experiment, we've shown that the solubility of the sugar and rock salt increases with higher temperature. Hot water can dissolve more sugar than cold water.
Sugar dissolves faster in hot water than in a room temperature and cold water because higher temperatures increase the kinetic energy of water molecules, allowing them to collide with sugar particles with greater force, breaking the bonds holding sugar together. This increased molecular movement results in more efficient and rapid dissolution. In contrast, in colder water, the slower moving molecules have less energy to break these bonds, leading to a slower dissolution rate. But what actually happens when we dissolve something on water? When you dissolve something in water, the molecules of the substance break apart and mix with water molecules. This process creates a homogeneous solution where the dissolved substance becomes evenly distributed, altering the taste, color, and often other properties depending on the specific substance dissolved.
I've been running through the jungle, I've been crying with the wolves to get to you, to get to you, to get to you.
After knowing the effects of temperature in dissolving substances, let's now move on investigating the effects of particle size and mixing on solubility. Take a closer look. We can see that the sugar dissolves more quickly than rock salt in hot and room temperature water, because its molecular structure is more soluble and easily breaks apart in the warmer conditions, allowing it to mix with water molecules faster. In cold water, both sugar and rock salt dissolve more slowly because lower temperatures reduce the kinetic energy of molecules, making it harder for them to overcome the forces holding the solid particles together. When sugar and rock salt are added to a glass of water but not mixed, they tend to settle at the bottom of the glass because of gravity. The lack of mixing means there's limited contact between the water molecules and the sugar or salt particles, which is crucial for dissolving. Consequently, the particles don't fully dissolve in hot, cold, or room temperature water, resulting in them remaining at the bottom as undissolved sediment. This happens because the solubility of these substances in water is temperature dependent, and without proper agitation, they won't evenly disperse and dissolve.
So, what did we learn from the experiment?
We found out that the temperature of the water affects how quickly the substance with different particle sizes dissolve. Smaller particles like sugar dissolve faster in warm and hot water, while larger particles like rock salt dissolve more slowly, especially in cold water.
This experiment helped us to understand the particle size and temperature in the process of dissolving substances. It's an important concept in chemistry.
In conclusion, when anything is dissolved in water, its molecules separate and combine with the molecules in the water, depending on the particular component dissolved. This procedure produces a homogeneous solution where the substance that dissolves is evenly distributed and changes the taste, color, and often other characteristics. Dissolving different solids in various liquids can exert a profound influence on the boiling and freezing points of those solutions. This phenomenon, known as colligative properties, occurs due to the alteration of the solvent's physical properties when solute particles are introduced. When solutes dissolve in a liquid, they disrupt the solvent's ability to change phase, either from a liquid to a gas, which is boiling point, or from a liquid to a solid or freezing point. The result is a rise in the boiling point and a decrease in the freezing point, both proportional to the concentration of solute particles.
And that's where our experimentation will end. Thank you for joining us in this experiment.